This is Pre-Calculus Part 1, Section 4.3, Right Triangle Trigonometry, page 491 to 492, Example 1, Evaluating Trig Functions. The first thing that's going to happen is they gave you two sides. One side is 5, one side is 12. So because we know this is a right triangle, we can use the Pythagorean theorem to find that third side. So 5 squared plus 12 squared is 25 plus 144, 169, so the square root of that is 13. And that's your third side, or that hypotenuse. Okay? And then you have to know the actual ratios. Sine is, here's our theta, it's this angle here. So sine is opposite over hypotenuse, so the opposite side is the 5, the hypotenuse is the 13 that we just calculated. The cosecant, of course, is the reciprocal of that, hypotenuse over opposite. Cosine is adjacent, which would be this side, over hypotenuse. So 12 over 13, and again, the secant is just the reciprocal of that. Tangent, you can either do sine over cosine, or you can do the opposite side, which would be that 5 over the adjacent side, which is 12. 5 over 13 over 12 over 13 would reduce to this as well. And then cotangent is the reciprocal of that, which would be 12 over 5. Okay, so if we're going to do the checkpoint, it's all the same. They gave us one side was 3 and one side was 4. We're looking for the hypotenuse. So 3 squared plus 4 squared, 9 plus 16 is 25, which means C is 5. So your hypotenuse is 5. Here's the theta. That's the angle you're talking about. So the sine would be opposite, which is 3, over hypotenuse, which we said was 5. Cosecant is its reciprocal. Cosine would be adjacent, which is 4, over the hypotenuse, which is 5. The hypotenuse cannot be the adjacent side. The hypotenuse is the hypotenuse. So yes, this has two adjacent sides, but one of them is the hypotenuse. So the adjacent would be the other side. So be careful with that. Cosine is 4/5. Secant would be the reciprocal of that, which is 5/4. The tangent is opposite over adjacent, so 3 over 4. Opposite over adjacent, 3 over 4. And the cotangent, of course, is just the reciprocal of that one.